Around 3.7 billion years ago, just north of the equator on Mars, a flash flood picked up a large boulder and carried it into a fast-moving river. The boulder was transported downstream into a delta, where the river met a lake formed inside a giant crater, 45 kilometers wide. This crater had been caused by an asteroid impact long before. Finally, the boulder splashed into the crater lake, sinking to the bottom. Floods like this were common on ancient Earth, but this wasn't Earth. It was Mars. At that time, Mars was much more Earth-like, with large bodies of liquid water on its surface, a protective atmosphere, a warmer climate, and perhaps even life. However, today, Mars has none of these features. Over eons, we've often discussed the dramatic changes Earth has experienced, but Mars has undergone its own fascinating transformation. Although we've been observing Mars for centuries, it is only in recent years, thanks to our curiosity and persistence, that we've started to understand what happened to it. So, what caused Mars to change from a warm, wet, potentially habitable planet to the cold, dry, lifeless one we know today? The core reason seems to be that, although Mars and Earth shared surface similarities in the past, their internal processes followed very different paths. Throughout history, Mars has been viewed in many ways. The ancient Greeks considered it one of the wandering planets, and its red hue led several cultures to associate it with war and conflict. However, it wasn't until Galileo peered through a telescope in the early 1600s that our perception of Mars changed. No longer just a mystical body in the sky, it became a physical planet with its own landscapes and geological features. This discovery sparked a new question. Did anything live there? For a long time, we could only wonder, but we didn't have the technology to seek answers. It wasn't until the 20th century, when our technology advanced, that we began to investigate Mars more directly. We sent orbiters, landers, and rovers, which revealed a dry, rocky, barren world with no clear signs of life. However, these missions have also helped us learn more about the planet's past. For example, the Perseverance rover, which landed on Mars in 2021, is exploring an ancient lakebed in a crater, searching for evidence of past life. Mars's transformation began with a thick atmosphere and a warmer climate, making it suitable for life. To understand how it changed, we need to look back to the planet's formation. Like Earth, Mars formed around 4.6 billion years ago from dust and rocky debris. Both planets had partially molten iron cores that generated magnetic fields, which protected their atmospheres. Earth's magnetic field still shields us from solar wind, but Mars lost its magnetic field millions of years ago. This exposed its atmosphere to the harsh solar winds, which gradually stripped it away, leaving Mars cold, dry, and unable to support liquid water. Mars's smaller size compared to Earth meant that its core cooled faster, causing the planet's magnetic field to shut down. Without this protection, Mars's rivers, lakes, and oceans vanished, and the planet's atmosphere thinned, leaving behind valleys and lake beds. These features are prime targets for searching for evidence of past life. Could life have survived in underground reservoirs or near the polar ice caps, where liquid water might still exist? Life on Earth shows that even in extreme environments, life can adapt and thrive. If life did exist on Mars, could it have persisted, hidden beneath the surface, or could traces of it still remain after billions of years? In 2018, NASA's Curiosity rover found methane in Mars's atmosphere, which on Earth is often produced by living organisms. This suggests the possibility of microbial life underground. Both Curiosity and Perseverance have also discovered organic molecules in Martian rocks, some of which are over 3 billion years old. Organic molecules are the building blocks of life, and their presence raises a question. Could Mars have supported life at some point? While we haven't found definitive evidence yet, there are 3 main possibilities. Mars never had life, Mars had life but it died out, or life on Mars still exists today in some form. To answer these questions, scientists are planning to return samples from Mars to Earth. In late 2022, Perseverance collected rock samples and sealed them in titanium tubes for future retrieval. In the early 2030s, a robotic mission will bring these samples back to Earth, where they will be studied in more detail. These samples could help us answer the long-standing question of life on Mars, and discovering the truth would change our understanding of life itself. Could life on Mars share common traits with life on Earth, or is it completely different? Studying Mars's past might even offer important lessons for the future life on Earth. Could life adapt to extreme conditions, or is it possible for an entire biosphere to vanish if conditions worsen? These are questions that are critical to understanding both the history and future of life on Earth.